This is Algebra 2, Semester 2 final review on trigonometry. So here we want to solve the following triangle. We can see that angle C is a right angle, which means we can just use sine, cosine, tangent. So we can use SOHCAHTOA to help us solve this. We know one angle is 27. We know this angle is 90, so we can easily find the third. You can add 90 and 27 up, and then subtract from 180 to get the third. Or because this is a 90-degree angle, you know your other two angles have to be complementary, so you could just take 90 minus 27. Doesn't matter which way you do it. Either way, you're going to get your third angle to be 63 degrees. So angle A is 63 degrees. Now we need to find side B and side C. So I'm going to do this with respect to the 27. So with respect to 27, side B is our opposite, 10 is our adjacent, and C is our hypotenuse. So we know the adjacent, which means we could use tangent of 27 is the opposite side B over adjacent of 10 times by 10 to solve for our B. So 10 times the tangent of 27. B is equal to 5.1. So 5.1 for our side B. To find C, the hypotenuse, we know adjacent. So adjacent and hypotenuse would be cos, so cosine. So we'll take cosine of 27 is equal to the adjacent 10 over the hypotenuse of C. The 10 is in the top, so to move the C over, you'd have to times by C, and then divide by your cosine of 27. So you end up having 10 divided by the cosine of 27 is equal to C. And so that gives us a value of C of 11.2. So your C is 11.2. So there we solve the triangle. We can also solve triangles that are not right triangles. So we want to decide if we're going to start by using the law of sines or cosines and then solve the triangle. Here we can clearly see A is 4, B is 8, C is 5. We have no angle measurements, which means it's law of cosines. So then we're going to find the largest side first. So we're going to start with the 8. So 8 squared would equal 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of B. And once again, that's just following our law of cosines. That says A squared is equal to B squared minus C squared minus 2BC times the cosine of A. So you got to figure out that 8 squared is 64. 4 squared plus 5 squared, 16 plus 25 is 41. Minus 2 times 4 times 5 is 40 times the cosine of B. Solving for cosine of B, we still first have to subtract our 41. So 64 minus 41 is 23, which is equal to negative 40 times the cosine of B. Divide by negative 40. And since we're looking for an angle measure, we have to take the inverse cosine of whatever decimal we get for 23 over 40. And you can certainly also do 23 over negative 40 and just use that for your inverse cosine. That's also perfectly acceptable. But either way, we end up getting an angle B of 125.0996. So our angle B then, we would say to the nearest degree is 125 degrees. So now using that, we're going to now do the law of sines. So I have my angle B. My side opposite of B is 8. So we will start off with our sine of 125.0996 over our side B, which is 8, is equal to the sine of angle A over 4. So times both sides by 4. And it doesn't matter if you find angle A first or if you find angle B first. Doesn't matter which way. But then we get 0.409 here for sine of A. So to get A, we would take the sine inverse of that value. So we end up getting an angle A of 24.1468, or rounded 24 degrees. To find your third angle, you will add 24 and 125 up, and then take 180 subtracted off that sum. So when we do that, we end up getting our third angle of 31 degrees. So there we solve the right triangle. Or there we solve the triangle. Excuse me, it's not a right triangle. There we solve the triangle using law of cosines.